Alright, so this is class 4 of chapter 10. We're going to apply our stuff with radicals to the Pythagorean theorem. So, what kind of triangle do you need to use the Pythagorean theorem? Well, you need a right triangle. And then, which side is the hypotenuse? It's always the one that is opposite the right angle. So remember, a right angle is a 90-degree angle. So if we're looking at something like this, this would be our right angle. It's a 90-degree angle. So that makes this the hypotenuse. And we call these two the legs. Okay, and our relationship is a squared plus b squared equals c squared. That is the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. Alright, now I'm going to do a couple of problems. There's also going to be a couple little things with radicals in here, like when I square this, I want you to pay attention. Also notice that here's our right angle. In this one, our x is the hypotenuse. Here's our right angle. So here our hypotenuse is 10. X is not the hypotenuse, so x is going to be one of these. So let's set up a relationship. A squared plus b squared equals c squared. So c has to be the hypotenuse. And then a and b, it doesn't matter which, and these are the same numbers, so it doesn't matter which we call a and b. So that gives us 5 squared plus 5 squared equals x squared. Alright, now I'm going to crunch these numbers, and once I have one number over here, I'm going to take the square root of both sides. So it's 25 plus 25 equals x squared, so 50 equals x squared. Also notice how I'm writing this correctly, keeping my equal sign lined up, and writing both sides of the equation every time. Not just doing a little bit of work here and a little bit of work there and hoping that I can get the numbers at the end. Alright, the neater you do your work, the better. So now I'm going to take the square root of both sides. So the square root of x squared is just x. The square root of 50 is not simplified, so we got to finish simplifying that. Now, based on our prior lessons, so if you don't remember how to do this, go back to lesson 1 on simplifying radicals. 50 is equivalent to 5 times 5 times 2. So to simplify that, we take every pair, and for every pair there's 1 on the outside, and we get 5 root 2 equals x. Alright, now I got the 5 times 5 times 2 by doing the prime factor tree of 50, which you should look at class 1 if you don't recall how to do that. Alright, so now our pardon me, our variable is one of the legs. So number 10 is our c squared. That's our, or that's just our c. Our c, that's our hypotenuse. So if I'm doing a squared plus b squared equals c squared, then that gives me, I'll call this a, and I'll call this b. It doesn't matter which one I call which, just as long as they're on the left and the hypotenuse is on the right. So I have 6 root 2 squared. Now not this, not just squared like that, but the whole thing is squared. Alright, that's crucial. So make sure you square the whole thing. Plus x squared equals 10 squared. So I'm going to do this part right here kind of off to the side so that you don't get lost in what I'm doing here. So that is 6 root 2 squared. So I've got to apply that exponent to each of the numbers in there. So that's really a 6 squared root 2 squared. So it's a 36. Square root of 2 squared is just 2. So it's a 36 times 2, which is a 72. So this equals 72. So we have a 72 plus x squared equals 10 squared is 100. So that's 100. And now we're just solving this simple equation. Minus 72, and we get x squared equals 100 minus 72 is 28. And now we can take the square root of both sides. Alright, that gives us an x over here. Technically it should be the plus or minus square root, but it's a distance, so it can only be positive. So x equals root 28. 28 prime factorization is 2 times 2 times 7. Again, if you don't recall that, go back to video number 1. So for every pair, we pull out 1. So that gives us x equals 2 root 7. This is our simplest radical form. So on your u-tries, come back and watch this if you need to. On your u-tries, when it says leave in simplest radical form, there should be no decimals. If you get any decimals, you should just leave it as a fraction, not as a decimal. And simplest radical form is when you have simplified it as much as possible, like this. Alright, so I don't want to leave it as square root of 28, I want to leave it as 2 root 7. So here is your u-try. You have 4 examples here. Notice that these x's are the hypotenuse, whereas these, this is the leg. This is again the hypotenuse. Also take note of when you're squaring numbers versus squaring square roots. Alright, and we'll see you tomorrow.